All right, so today we're looking at lesson 26. We're going to look at fluid pressure, weight, density, and pressure, fluids at rest, and Pascal's principle. So hopefully after this lesson you'll understand fluid pressure, weight, density, and pressure, fluids at rest, and Pascal's principle. Your average pressure on a surface equals the total normal force acting on the surface divided by the area of the surface. So that's going to give you this formula here. Your average pressure is the total normal force divided by the total area. 1 Newton per square meter is called a Pascal, and it's abbreviated PA. So your total force is the force over area times area. Force per unit area is pressure, and so we can also use total force equals pressure times area, because force over area is the same thing as pressure. So this is the formula we're going to be using. F equals PA a little bit. At any point in a fluid, the pressure is going to be equal in all directions. If you think about swimming in a swimming pool and you go 3 meters or 3 feet below the surface and then you swim towards the deep end of the swimming pool, the pressure is not going to change as long as you stay at the same depth. Now if you start swimming down more, if y'all have ever done that, you've probably felt your ears start to pop. You may need to swallow to make them feel better, but that's because the pressure is starting to get more intense the further down you go. The numerical value of the weight of each cube, if you look, is the same as the numerical value of the pressure on the bottom of each cube. So this is the kilograms, 1,000 kilograms. And then if you multiply it by the pressure that is pushing down at the bottom, you're going to get 9,810. So the book tells us if we let volume be a unit cube, then density tells us the mass of the unit cube, and the density of fresh water at standard pressure and temperature is 1,000 kilograms per cubic meter, which is what you have on the left. 1,000 kilograms and then meter or cubed. And so the mass of this block is the 1,000 kilograms, and if you multiply it by the 9.81, you get the weight of it in newtons. And this is the same as the pressure of the bottom of the cube. So the weight of the cube is 9,810 newtons, and the area of the base is 1. So if you do average pressure, the weight, the pressure, the force, the weight is the same thing as a normal force. And then you divide it by the total area. The area of this is just a 1. That means that the pressure on this is 9,810 newtons per square meter. If we do 3 cubes, then that's going to change what the pressure is. That's like if we were down here, we're in the pool, and then we decide to swim further down, well obviously the pressure is going to get greater. And it's going to end up being 3 times the 9,810, so 29,403. So if you look at fluids at rest, the average sea level density of air at standard temperature and pressure, so that's 25 degrees Celsius and 1 atmosphere, is 1.29 kilograms per cubic meter. So 1 cubic meter of air at sea level weighs about 12.7 newtons. 1 atmosphere of pressure is 101,300 newtons per square meter. That's going to be a number that you're probably going to want to write down on your formula sheet, just so that you have it to reference back to. If you have a fluid at rest in a container, the pressure at all points at the same depth are equal. So if you look here, the pressures at A, B, C, D, and E are all the same because the vertical distance from the top here down to A, down to B, etc. Those distances are all the same. And so the pressures at those points are all the same. It doesn't matter the shape of them, it's still the same pressure. So you may have heard of Pascal. He's a French mathematician and physicist. He made an observation that now bears his name. One thing that you may have heard of is Pascal's triangle. It's where it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, etc. He also made Pascal's principle. And that is that the pressure applied to an enclosed fluid is undiminished to every part of the fluid. So the pressure over here is going to have to equal the pressure over here. So P1, that's your pressure, equals your force normal divided by your area, which you could also cross multiply to say PA equals F. So PA equals F. You can do any of those three formulas for these. But that's his principle there. So looking at an example, on a particular day, the atmospheric pressure was 101,000 pascals. What was the pressure at a depth of 94 meters below the surface of the sea? And it tells you density of the seawater is 1,025. So we need to know what is the weight of the seawater. So weight is just equal to mass times the gravity. So the mass is 1,025, and then gravity is 9.81. And so if you multiply, you're going to get 10,055. And then we want to know how far if we went 94 meters deep. So for that one, the total weight, we're going to take 10,055 and multiply it by the depth that we're going to. So multiply it by 94. And that gives you 945,170. And so that's the pressure from the seawater. However, we also have the pressure from the atmosphere. So we have to add the 101,000 to give you a total of 1,046,170. And so then we have to go back to our sig figs. This number only has 3 sig figs. This one has 4, and that one has 4. So our final answer has to have 3. So we're going to stop with this 4. So 1.0, it's going to round to a 5, and then times 10 to the 6th. And we want to know pressure. Those units are pascals, so PA. And that would be your answer. So you have to make sure that you include the atmospheric pressure on these. If they didn't give what it was, then you would use that number that I told you might want to write down. 101,300. Okay, so let's look at another example. The fluid in the tube is glycyrrhizin. I think is how you say that. Whose density is 1.26 times 10 to the third. The pressure is 1.013 times 10 to the fifth. What is the pressure P in the container? And the depth of B is 14. Alright, so for this one, we are wanting to find what is the pressure P in our container. So what is the pressure here? The pressure on the left and on the right have to be equal. And so the pressure on the left is P. And then there's also the pressure of this X depth. We don't know what it is. And then on the right side, we have the atmosphere's pressure. So I'm going to write P of the atmosphere. You also have the pressure of the 14 centimeters deep. And then you have the pressure of the X part. And if you notice, the pressure of the X part is the same on both, so that cancels. So we really just have the P, the pressure of the atmosphere, and the pressure of the 14 centimeters part. So the pressure of the atmosphere, they tell you, is this number here. So I can say 1.013 times 10 to the 5th. And we're looking for P. And then we're going to have to be able to figure out P sub 14, the pressure of the 14 centimeter part. So they tell us the density of the fluid is this here. And so we need to find the weight of it. So the density is 1.26 times 10 to the third. So that means that the mass is 1.26 times 10 to the third. And then we're going to multiply it by 9.81. And you get 12.36 times 10 to the third. If you want to write that in scientific notation, you can. You don't have to. And then we're going to do, to get the pressure, we're going to have to do the weight, which we just found, times the depth. Now the depth has to be in meters, and they gave it to us in centimeters. So we're going to have to do 0.14 instead of 14. And so then you're just going to add these two together. And you should get 103,030.4, and we're going to round to 3 sig figs because that's the fewest number we have. So 103,000, or 1.03 times 10 to the 5th. So either one of those would work for your answer. Okay, so that's how you would set these up. You have to just balance the left pressures and the right pressures. Looking at one more example, they tell us the pressure produced by F1 and area 1 is transmitted through the fluid. Find the resulting F2 force on the piston with area of A sub 2. So this is where we're going to use a formula from Pascal's principle. The pressure on one side has to equal the pressure on the other side, and P1 equals F1 over A1. So we can actually say F1 over A1 equals F2 over A2. And then we can just plug in what we're given. So F1 is 75, A1 is 10. We don't know F2, that's what we're looking for, but A2 is 8. So then you can cross multiply. And divide by 10. Whoops, I left off the 0 on the 80. And so if you plug that into your calculator, you should get 600 And F1 was in pounds, so F2 is also in pounds. And so that would be your answer for that. So hopefully that helps you a little bit with lesson 26. Your homework is 1 through 20 and the curveball questions, so make sure y'all do those so we can go over any questions you have tomorrow.